Good evening, popular astronomers. It's Friday night. It's Pop Astro live from Astronomy Island. This is my map of Anglesey, an island off the North Wales coast, and I am just here really far out west. Obviously, if you're in the UK right now, the weather it's an evil evening, to say the least. And that is why we've got a very special topic for you lined up this evening, because chances are, if you've got your telescope out, you're probably somewhere in Tenerife or something. So how are you this evening? So my name is Vicky Duncalf. I'm the video blogger with the Society for Popular Astronomy. I'm very much a newbie into the sector, so I will be quite naive to a lot of the stuff that is happening in this broadcast, which is brilliant because it means I'm learning. And if you're very new to the topic of astronomy, welcome. We love to have newbies on board. It's what we are all about. So how are you anyway? Great. The great thing about this software that I'm using now is that you can comment and we can bring your comments on the screen and get you interacting with new friends. Also, you can post your questions and your queries, and there are astronomers on hand waiting to answer, which is one of the great things about the SPA. Expert advice whenever you need it on whatever topic you want. So, first of all, the weather has not been very good here. We're very far out here, west on Anglesey, and we are prone to power cuts. So if this broadcast just disappears, we've had 2 micro cuts today. So if my power goes off and the broadcast disappears, do not adjust your set. It's probably my problem, and I will try to power the broadcast back up and get back online as soon as possible. You'll just have to fish around for it in your notifications to see whether you can find the second half of the broadcast. Because Facebook sometimes does that, doesn't it? You're watching something and then it just disappears forever when it refreshes. Hopefully you can rejoin me, but even better, hopefully no power cuts, please. Just looking out at the big electrical transformer in our garden and praying to the god of electricity. Is there a god of electricity? That we have a stable connection this evening. So great. Have we got anybody joining us online? We've already got comments rolling in. Ian Baker. He spelled my name right. Evil evening, Vicky. That sounds like my superhero name. And Pippa is joining us. Oh, hi, Pippa. Hi, I noticed you're my new friend on Facebook. Hopefully you like astronomy as well. Are we going to do house sitting? Let me know. Wonderful, wonderful. Get the comments started up because they really do make the show. So, plug the mug, plug the mug, plug the mug, plug the mug, plug the mug. This one has got last week's lipstick on it. That's what you get for when your boyfriend washes up. My purple lipstick is on that, but still it's our beautiful SPA mug. We have got new ones at the popastro.com shop. Paul Sutherland, former newspaper hack, has been racking his brains trying to think of amusing slogans for our t-shirts and mugs. Please do get them. They really do make you feel part of something special. Plus they look great in the cupboard as well. I'll just add to the lipstick pile up. It's water tonight. So we've got our new t-shirt and new mug combi. You could have the both and do the double. Our new slogan says, amongst many other hilarious, witty astronomy-related slogans, such as Stirry, Stirry Night, and I make my drinks the Milky Way. Our new one, which I do believe might actually be an old one, an old slogan that we've had, astronomy is looking up. Question, do astronomers look up or down a telescope? You kind of look up it really, don't you? But you say look down it. What a crazy world us astronomers live in. So on tonight's lineup, we have got, I really apologise for what's about to come out of my mouth. Paul Sutherland wrote it. I don't know whether he meant for me to broadcast it, but I'm going to say it anyway because it tickled me slightly. Dave Oranges and Clements, Julian Knows His Onions, and Mark BBC Stargazing Thompson. They're the 3 big names that we've got on for you this evening. Mark's name doesn't really sound like a fruit or vegetable. So sorry that his name doesn't fit in with the little rhyme that Paul made up there. So Dave Clements, Doctor, to give him his correct title, is an astrophysicist and science fiction writer, continuing the long-standing tradition of scientists who write science fiction. He works at Imperial College London, where he specialises in observation cosmology and extragalactic astronomy. Now, when I was rehearsing this earlier and I read out that he specialises in cosmology and extragalactic astronomy, my boyfriend on the other side of the kitchen swore. My boyfriend's a joiner. And he heard those job titles and he swore. An impressive kind of swear, I mean. That is a respectful, impressed kind of swear. Dr. Julian Onions is a postdoctoral researcher at the University of Nottingham, and we've had some fantastic times at festivals over the years, so we'll be chatting about that. And Mark Thompson from BBC Stargazing will be talking podcasts, cosmology for beginners, and the latest hoo-ha on Betelgeuse. So, hello, everybody. Hello to James Webby Webster. Hello from Toms River, New Jersey. Doesn't everybody say it like that? I'll just pronounce it properly. New Jersey. There you go. Tony Davis, hi to you. Hello to Robin. Robin's on standby in case we get power cuts. Now, last week, Dave Graham, our lunar section director, apparently he was waiting in the wings, and the instant I said his name, he had a power cut and couldn't make it through onto the broadcast. That is the power of my voice. I say your name and it spins your electric out. So Dave couldn't make it last week and Robin stood in. So be on standby tonight, Robin, just in case. Detecting Orgut. Hello, Detecting Orgut. We've got Sandra Grace. Hi, Sandra, our newest member, or one of our newest members of the SPA. Great, from North Wales Astronomy Group. Very good to see you. And James Webby Webster, there we go. Says lol. Excellent. Okay, so we're getting motoring on through. We're going to be having our first guest any minute now. Where's he gone? We're already down a guest. So anyway, we should be having Dave Clements joining us any moment. Hopefully he got the memo that he needs to be online right now waiting for us. Otherwise, Robin, you've got a hell of a big pair of cosmological boots to fill. It's our cosmology special tonight. It's nearly a full moon. The weather is dreadful, so it's unlikely any of us are going to be using any telescopes. And if you do, good luck to you. So we're going to go big. Now, don't they say go big or go home? Well, we're all at home anyway, so we're going to go big as the Big Bang as it happens. So what is cosmology? Now, I've used the term myself and haven't really known precisely what it meant. I had a vague idea that it was something to do with infinity, the Big Bang, and baffled astronomers and frown lines, but I wasn't precisely sure what the accurate definition is. So according to Wikipedia, it is the science of the origin and development of the universe. Modern cosmology is dominated by the Big Bang theory, which brings together observational astronomy and particle physics. Now, if you want to implode on your own frown lines, I can highly recommend a page on Wikipedia that I found today called List of Unsolved Problems in Astronomy. So seriously, it's an amazing page. Do go and check it out. The page includes such fiendish questions as, what is the axis of evil? Have you heard of that? Now, in a very tiny nutshell, some large features of the microwave sky at distances of over 13 billion light years, this is like right at the forefront of the universe pretty much, appear to be aligned with both the motion and orientation of our own solar system. Another question on there is the universe heading towards a big freeze, a big rip, a big crunch, or a big bounce? Or is it part of an infinitely recurring cyclic model? Well, someone needs to tell the universe that yo-yo diets don't work. And another unanswered question in astronomy that I found on this page: the vast, beautiful rings of Saturn are a highlight of the solar system. But can anyone recommend a place where Saturn could purchase some nice matching earrings too? He's got to have the set. Right, so I can hear people joining me on the broadcast. We've got Dave, Robin. It's okay now. We've got Julian. Okay, we've got people lining up to be on. I'm going to cut to Julian in a minute because we are down a guest apparently. Let's have a quick check of my emails. Okay, Julian, we're going to be coming to you in a couple of secs. In fact, I'm going to come to you right now, Julian. I'm going to come to you right now. And I can show you my new space pants. Are you ready, Julian? In 3, 2, 1. This is like Noel's house party. Julian!
Oh, wow, that was seamless.
Hi, how are you?
Good, thanks. How are you?
I'll show you another thing. I'm really good, Julian. I am just fiddling with a setting here. Just bear with me.
Is that adjusting your space pants?
Julian, guess what? Do you see what's just arrived? I've just got some new space pants in the post. Did you see it on my Facebook?
No, I didn't. Oh, Dave Galvin will be so pleased.
Julian, this is amazing. Well, my space pants have been in the wash that many times that they're kind of just looking a bit flaccid now. But just earlier, about an hour ago, news.
Oh, wow.
My friend posted me these from Australia.
Wow.
How's that?
Oh, man, amazing.
So, I'm sweating slightly in my new space pants, but they do look fantastic. How are you, Julian? It's so good to see you. I've missed you.
Thanks. Yeah, I missed you.
We're normally cavorting at ridiculous events like Solar Sphere, aren't we?
Yeah, but what happens at Solar Sphere stays at Solar Sphere.
Usually standing around with a pint in our hand, listening to very, very loud music.
Very much so.
Oh, we're missing Solar Sphere. That is the festival that Pete Williamson organises, and amazing team. And it's just a brilliant family festival, sadly cancelled this year, but hopefully next year, Julian, what do you think?
Oh, I think so. I think we can rock it hard then.
Yes, it's going to be so good, isn't it? Your name is massive on this screen, isn't it? Well, you've got top billing here, Julian. How can I make it smaller? Let me have a little go. It's bigging you up big time, isn't it? Let's see. I might just be able to change it to Pop Astro Cosmology Special. It's got rid of your name now, but there we go.
Better, yeah.
Oh, Julian! Excellent. Okay, so Julian, it's so good to see you. Would you just like to explain who you are and what you do, please?
Well, I'm a sort of astronomer. At least I am part-time. And when I'm doing astronomy, I do sort of big computer models of the universe. So I make universes for a sort of hobby and a profession.
No, that sounds fantastic. So that's not a particularly small job, really. What does making a model of the universe look like?
No, it involves a big computer. So you put it all into a big computer, give it a sort of electronic stir, and out pops a universe. So I can make you a universe in about 24 hours. I can freshly baked.
Wow! Could you make a Wikiverse where you put my parameters in, please? Like everyone has to wear. Yeah. Everyone has to wear space pants.
I don't think I can fine tune it to that amount.
So, like, what kind of parameters would you put in it then?
Oh, well, we put in sort of basic cosmological parameters, things like Hubble constant and the force of gravity and things like that. A lot of boring stuff, really. And then we start it with an initial recipe and then put it on the computer and let it simmer for 24 hours and then prick it with a fork to see if it's done, bring it out and then see if it looks like anything you want to consume.
When its juices run clear, it's ready.
Exactly that, yeah.
So I'm assuming you're not doing this on a little tiny laptop then. How big are the computers?
Not usually, no. We can do it on a reasonably small one. Well, we have a sort of biggish one at Nottingham with, I think it's got 2,000 CPUs on it. But I'm not allowed to use all 2,000 because engineers and mechanics and biologists and chemists all want a bit of it. So we usually get about 100 of those to run a model. And with that, it takes about 24 hours.
And how much space does 100 CPUs fill up, Peb?
Not that much, actually. It's remarkably small. It's diminishing as CPUs get smaller and smaller. But I have run one on a place in Switzerland called Pisdaint, which is named after a mountain there, I think. And that had 128,000 CPUs and so much disk space you could see forever, basically. So
wow.
We ran that. We had about a year to run that in, but it didn't run for a year. You sort of run it for a bit. It all falls in a heap. Then you pick up the pieces and scratch your head a bit. Then you have another run and keep going until you've got it. But they got like, I guess you got a terabyte of space maybe on your laptop. This has got petabytes. So a petabyte is 1,000 terabytes, and it's got like 50 petabytes. So you just look at this amount of space and think, wow, I could fill that. And it's shockingly easy to fill it very quickly. And the problem is, once you've filled it, then I have to get it back to Nottingham. And you realize how big a petabyte is then when you're sitting there at a sort of an internet connection trying to get a petabyte of information back across the internet.
I bet that takes a while, doesn't it? I don't think it'd happen on embassy Wi-Fi.
2 or 3 weeks it took.
Wow, Julian, that's amazing. Actually, I've met you loads of times and I did not know this is what you did for your day job. I'd be following you around even more next time I see you. Guess what I've got on my hat here? Can you see it?
Oh, you got the Onionets badge.
Who was it? Who made these? Was it Sybil, Pete's wife, or maybe Sarah? This is from Solar Sphere. This is an Onionets badge that basically there's a big clutch of girls wear this, and we sit in the mosh pit at your lectures, screaming.
And it's very intimidating, yes.
Oh, I bet it is actually. How would I feel if I had I've never had a groupie. It'd be nice if I did. Julian, you could be mine. I can be yours.
You're my first, I have to say.
Excellent. So, what does all this information that you're modeling? What kind of stuff does it tell us?
Well, it sort of gives another view on the universe. One thing, well, we put in basic equations from physics, which are all really quite simple. You might think they're long, complicated things, but they're not particularly. They're fairly straightforward equations, but you have to do an awful lot of them, which is why you need the computer. So the first thing you do is you sort of run your model and end up with some data. You make a picture of it and see if it looks anything at all like the real universe. And if it doesn't, then you've messed up something somewhere along the way. If it does, then you've got a bit of confidence in the model. Then you can do things with it that you can't do with real observations. So you probably know the universe is composed a lot of dark matter, and we can't see dark matter with telescopes in any way, shape, or form, only its effects on other things. But in computer models, we can color it any color we like, and we can make maps of the dark matter. We can make pictures of it. It's usually colored purple for some reason. I think the first person to make one had it colored purple, so we all seem to color it purple. So we can get big maps of the universe with dark matter that we can't see. So we can then say, if you had a big galaxy, you would see lots of dark matter spread out a bit like this. And that should influence things in a particular way. You could perhaps turn your telescope, talking to some of my colleagues, and say, you should be able to see something like this. So why don't you go and have a quick look and see if what our prediction from the model says, does it look anything like that?
Thank you. So Paul Sutherland is asking, with super, look, he's got his head in his hands on that picture there. Quite apt, actually. How will astronomers manage with all the data, Julian? We're going to post it out to Paul Sutherland and make him work on it.
I think that's a very good idea. Yeah, I mean, certainly we generate a lot with the computer models, but other things are now generating a huge amount. There's a new telescope that was called the LSST, but it's now called the Vera Rubin telescope. And that's going to generate, I forget how many terabytes a night. So enormous amounts of data, because it basically scans the whole sky in very high detail and produces a very high resolution picture of all the galaxies and stars in the night sky every night at a phenomenal rate. And where we used to sort of set PhD students to look at the data and say, see what you can find in that, this thing will just overwhelm them all. So we're having to train computers to look for it.
Okay, busy computers. Okay, Julian, the question I ask myself every night when I lie in bed is, where's it all going to end? What's going to be the end of the universe? That's my number one question.
Where is the universe going to end? Now, that's a big question, and one, I have to say, we don't really know. So there's a couple of possibilities. One is the big freeze, where everything gets really cold and just settles out. That's sort of when everything is finished. We can't make any new stars or anything like that. So there's not a lot going on in the universe, and it just sort of settles down to do nothing. There is another one where we have a big rip, and that's sort of to do with dark energy, which is another embarrassment for astronomers. It turns out about 70% of the universe is made out of dark energy, and nobody realized until about 20 years ago. So one of the models of that is, so dark energy is this sort of force that we know almost nothing about, but it pushes things apart. And one idea of that we're not entirely sure about yet is that it might be the same. It might continue to push things apart, or it might get stronger as the universe gets older. And if it gets stronger, then it starts to push everything apart, not restricted to just pushing very distant galaxies apart, and it starts to mosey in and starts to push galaxies apart, and then stars apart, and then planets apart, and then finally atoms apart. That's the sort of big rip idea.
Right.
And there was the idea of the big crunch, which I think you mentioned at one point, which is where it sort of expands out and then gravity wins and it all comes back in and crunches again.
Uh-huh. And what's your money on, Julian? What's your money on?
I'm going on
for William Hill.
I'm going for the heat death, the big chill. The universe is just going to be chilled out and not doing very much. That's what my money is on at the moment. But having said that, I know almost nothing about any of these theories, so my guess is as good as yours. Pick your favourite.
Which one do I like that sounds best? I mean, the crunch one sounds absolutely terrifying.
Yeah, but you have to think all of these would happen over about 1 trillion years. So realistically, it's not going to worry either of us, I don't think.
I'm going to live forever, Julian.
Yeah, you're going to live forever. Okay. Just like
I've been listening to the Oasis songs. Julian, do you know Dave Clements?
I don't think I do. I think I know the name, but I probably should do. So
I'm going to bring him
come in and correct me.
Yes, I'm going to.
Sorry, not corrupt me.
Really embarrassing. So I'm going to have Dave on in a moment. So Dave is a sci-fi writer as well. So what I'm going to do is I'm going to bring, you see, I do business networking for a living, Julian, and I like to introduce people to each other. So I'm going to pop Dave onto the stream as well. Here he comes. Hi, Dave.
Hello. Good evening.
Hi, Dave. How are you?
Fine, thank you. Evening, Julia. Evening, Vicky.
Very good. So maybe you two can look each other up on LinkedIn. That's how you do it, isn't it? New friends on LinkedIn, besties on LinkedIn. So whereabouts are you this evening now, Dave?
I'm actually in Birmingham at the moment. I've been in Birmingham, which is where my partner lives, since the lockdown happened. So I'm usually in London at Imperial College, but I've been doing everything remotely for about the last 3 months, which has been an interesting experience.
Very good.
Talking to students, marking exams, students who are taking exams remotely, which is a bit of an imposition in many ways. So it's all been rather different and a little bit stressful. But now we kind of settle into a different mode over the summer break. And instead of teaching students, we write new lecture courses. So I'm working on a new lecture course, which is called Origins, which is all about where things come from, including the universe, stars, planets, and origin of life stuff as well. Wow. So we're looking at the beginning of everything, where you've just been talking about the end of everything with the big rip.
So, Julian, did you read any sci-fi?
I'm sorry, I didn't quite catch that. Can you repeat it?
Do you read any sci-fi?
Oh, I read copious amounts of sci-fi. I can't say I've read any Dave Clements.
I have a short story collection out called Disturbed Universes, which comes from a small press publisher. So you can go and look for that if you really want to see what I'm about.
Very definitely.
Thank you for giving us your time this evening, Julian, and explaining all about your amazing adventures in computer universe land.
Right.
Okay, Julian, see you soon, hopefully.
See you soon. Bye. Cheers.
Bye. Bye-bye.
Bye.
Great, Dave. That just makes the two of us. How are you this evening?
Oh, not too bad. Just had my dinner, as I said. So yeah. I'm ready to go.
Excellent. Okay, so I'm going to start grilling you like a cheese sandwich with the questions.
Okay.
Grilling you like cheese. Okay, so yes, thank you very much for coming on this evening. So what area of astrophysics do you work in then?
Largely extra.
Oh no. Who's frozen? Is it Dave or Vicky? And there he is.
Oh, are we okay again?
Yeah, I'm just going to shut some windows on my laptop. How about you? Have you got any windows open?
I can close some things down. Let's see. Shouldn't have too much running. Just give me a second. So let me get rid of that. And get rid of that. And get rid of that. Oh well, that's a few things closed down. Are you still there, Vicky?
I'm still here. Yeah, you're full screen now. The floor is yours. So tell us what area of astrophysics you work in, please.
So largely extragalactic astronomy and observational cosmology, so looking at distant galaxies. I'm an observer rather than a theorist. So Julian and his colleagues come up with ideas about how the universe might look, and I go and look at the actual universe and tell them whether they're right or wrong. And being an observer, it's kind of like being a bowler at cricket. You keep throwing balls, i.e. in your observations, at the theorists, and they keep hitting them away because their theories are right. But you always hope for that googly ball that's going to get through and take their wicket and show that the theory is wrong.
That's a really lovely way of explaining it. I don't understand cricket. I'm only just understanding cosmology, but I understood both of that. I understood that.
Good, good.
So what big projects have you worked on then, Dave?
So most recently, the large programs I've been working on have been the Herschel and Planck missions. So the Herschel missions are far infrared space telescope. So that's working at wavelengths from about 70 to 600 microns. So far longer wavelength than you or I can see. And this is produced by material that's got temperatures of maybe 30 to 100 Kelvin, so 30 to 100 degrees above absolute zero. So we're looking at dust in space with that, and dust in our own galaxy, dust in other galaxies, and galaxies that are dominated by dust, which is pretty much my sort of thing, galaxies that are very dusty. So that was one big project. And at the same time, I was also working on the Planck mission, which was to look at the cosmic microwave background. So this is the dull glow left behind by the Big Bang. And to do that, it surveyed the entire sky at wavelengths from about 500 microns to a few centimeters in wavelength. And it needed to do that because if you want to look at the microwave background, which is the oldest light in the universe by definition, it's when the universe became transparent to electromagnetic radiation. So you literally cannot see further back with electromagnetic radiation. And if you want to go and look at what is the oldest light in the universe, you're looking past everything in the universe. That's stuff in our own solar system, stuff in our own galaxy, nearby galaxies, and then galaxies out throughout the entire history of galaxy formation and evolution. And you've got to measure all of that and take it away so that you're left with the microwave background. And so in terms of research interest, I worked on various things to do with data analysis and managing some bits of software development, etc. But in terms of the actual science that came out of the Planck mission, I was more interested in the scraps on the floor, the galaxies, the dusty galaxies that were being thrown away by the people looking at the microwave background. And we found a number of interesting things about nearby galaxies and about more distant galaxies. And especially when you join Herschel and Planck data together. So Herschel and Planck were launched together on the same launch vehicle, an Ariane 5, back in May 2009. And Herschel ran for about 4 years, just under 4 years. And Planck ran for a bit more than that, at least one of its instruments did. And one thing we found when we started looking at what's technically called compact sources, so these are things that Planck didn't show any structure in them. Planck's got a very large beam. How can I explain that? It's not very high resolution. It's kind of like looking at the sky with your eyes screwed up, so you can't see details of anything. But still, it's designed for looking at the entire sky rather than individual point sources. But you've got to find the point sources and throw them away, otherwise they're going to mess the microwave background up. So I was looking through the compact source catalog of Planck and comparing that to sources that we'd seen in large Herschel surveys. So Herschel didn't cover the entire sky, but it covered a fair amount, about 1,000 square degrees in total for extragalactic observations. And most of the Planck sources that are in the Herschel surveys, at least the Herschel extragalactic surveys, we find nice big nearby galaxies like our own, spiral galaxies that are forming stars. But sometimes you don't find a nice big Herschel source that correlates with a Planck source. What you find instead is a group of them, much smaller in size on the sky. Then they don't seem to be associated with anything in any optical catalog or any other catalog that we know of. And these look as if they are groups of dusty galaxies, which are all in some physical structure at great distance. And the thought behind what these are is an early stage in the formation of galaxy clusters, when several galaxies that will be members of the future cluster are forming stars very rapidly at the same time. And a few of these have since been confirmed by further observations. But there's a bit of a mystery here, that why should half a dozen galaxies in a young forming galaxy cluster all start producing lots and lots of new stars at the same time? And we don't know the answer to that. And this is one of those possibly googly balls that we bowled at the theorists, because these kind of dusty protoclusters, as we're calling them, don't seem to come out from the computer models of the early stages of galaxy cluster formation at the moment. You have to try very hard to make them, and it pushes our ideas of galaxy formation and galaxy cluster formation rather hard. And so that's one of the things I try to do. So that's sort of looking backwards, and it's work that's ongoing at the moment. I've got a PhD students working on this. Looking to the future, I've got another big project which hopefully will be happening. And this is kind of a follow-up to Herschel. It's called Speaker. I cannot remember what that stands for at the moment. Very embarrassing, because I'm the UK project scientist for the Speaker mission. And Speaker is a follow-up to Herschel. Herschel had a very big mirror, 3.5 meters across. It was the largest astronomical mirror ever launched into space. Still holds that record. We have to be very careful about saying astronomical mirror, because there may be other larger mirrors up there for other purposes, which we're not allowed to know about because the spy agencies won't tell us. The James Webb Space Telescope, which will be launched sometime in the next few years, will have a 6.5 meter mirror, so that's going to beat the Herschel record. But Herschel still holds the record at the moment. So Speaker is going to be a smaller telescope, about 2.5 meters across, but it's going to have one very powerful key difference that means that in some respects it'll be factors of 100 to 1,000 times more sensitive than Herschel. And that's because its mirror is going to be actively cooled to just a few degrees above absolute zero. The Herschel mirror, which was allowed to cool just by radiating heat away into space, was at a temperature about 80 degrees above absolute zero. So the mirror on Speaker will be about 10 times cooler, which means the background we get from the heat coming off the mirror itself will be down by a factor of 10,000 compared to Herschel, and that's what boosts the sensitivity, which means we can do a whole lot of extra things that we couldn't do with Herschel, and we can get into what's called spectroscopy, where instead of just looking at an image of the sky, you can actually take the light from an individual source and dissect it up into its individual wavelengths. And that's very important, because that enables us to look at the physics and chemistry of the objects that we're looking at. So from the point of view of extragalactic astronomy, we can look at one of these dusty galaxies that I've been working on with Herschel, and we can say with actually quite very good accuracy how much of the energy being generated in that galaxy is coming from star formation and how much is coming from accretion onto a supermassive black hole. So this is what's these are the things that power active galactic nuclei, and they can put out an awful lot of power in a galaxy. But if you surround that supermassive black hole and all the material falling onto it and generating energy through release of potential energy, if you surround that supermassive black hole by dust, you can't see the supermassive black hole and all the high energy stuff that's going on. The dust just warms up, and it doesn't look that much different from that dust being heated by young stars.
So we've got a question here from Richard Bottle, who looks like an orangutan. No offense meant, but how old are the protogalactic clusters then?
Well, actually, they're not. These are yes, proto-clusters of galaxies. Sorry, that's the way I would put the terminology. These sorts of objects we're looking at they're at redshifts of about 2, 3, 4, maybe up to redshifts of 6 in some cases. So we're looking at them when the universe was for the most distant ones, when the universe was just, to do a quick calculation in my head, about 700 or 800 million years old, and more recent for lower redshifts. So these are among the very, very first big structures in the universe to form, and that means that when we look at them, we are actually, at some level, we're also probing the physics of dark matter, because it's the gravitational attraction that comes from dark matter, which is the dominant gravitational source of gravity in large-scale structures in the universe. We're kind of probing the distribution of dark matter with these, and seeing how the dark matter influences the collapse of normal matter, and thus the formation of galaxies and also galaxy clusters. So the things we're looking at, they are 10 billion years old, and at 10 billion years ago, I should say, and further ago than that. I hope that answers your question.
I think that answers, well, I certainly can't. Yes, thank you very much for that. Wow, I'm just trying to take it all in. Fantastic. So what's it actually like to go observing then, Dave?
Well, if you're observing the Space Telescope, it's very boring. You sit at
you've just shattered all of my dreams there.
You sit at a computer, you basically do a preformed set of commands. That goes off to the observatory. They put it into their scheduling system and work out when's the best time for the Space Telescope to go and do your observations. You probably wait, 6 months, maybe a year if you're unlucky, and then at some point some data arrives. So it's very boring. That's why I also like to do a lot of observing from ground-based observatories, especially since space missions don't come along all the time. So at the moment, I'm in a phase of using ground-based telescopes to do follow-up observations of the things we've found with Herschel and Planck. Maybe in a few years' time, I'll be doing some more observations of those with the space-based telescope, like James Webb. But we'll see how that goes. So for ground-based telescopes, there are some that are just as boring as space-based ones. So things like the VLT, Very Large Telescope at the European Southern Observatory in Chile. Most of the observing on that is done, somebody does the observations for you. You send some commands off and they come back. Much more fun is when you actually get to the telescope yourself. So I usually end up going to Mauna Kea in Hawaii for observations with telescopes like the JCMT, the James Clerk Maxwell Telescope, and most recently I've been using the submillimeter array, which is run by the Smithsonian Institute in the US, and Subaru, which is run by the National Astronomy of Japan, National Astronomical Observatory, NAOJ, National Astronomical Observatory of Japan. So I was there in January. So you work nights, you're sitting on top of a mountain, which is so high, 14,000 feet, that you have to deal with the problems of altitude sickness, which can be really weird. You have jet lag. It's cold and windswept. It may be on top of a tropical island, but you're so far up that it's very cold. We had a lot of problems with snow while I was up there in January. We had to miss a couple of nights observing because of snowstorms. So yes, it's interesting. It's a fantastic place to visit, and there actually are you can have some tourist trips up there.
So we've got Ian here asking, does there seem to be that? Wow, what a great question. Does there seem to be the same relative amount of dark matter in the old clusters as there is in new ones?
That's a very good question. And it's not one that we can answer at the moment because our studies of the protoclusters are at a sufficiently early stage that we don't have the data required to be able to measure the amount of dark matter in them. It can be estimated from looking at some of the things that are happening, how the galaxies are moving, but we can't get an accurate measurement of it because I'm trying desperately not to use the technical term virialized here. And now I just
that's a good word. We can all use that in Scrabble this weekend.
Oh, I think it's a good one for that. So basically what that means is that your galaxy cluster has settled calmly into a nice sort of soup. And you can think of the individual galaxies here. So these are galaxies that are, got several hundred billion stars. We treat these individual galaxies moving around in a well-settled galaxy cluster as if they're point sources, point particles moving around in a self-gravitating system. And by seeing how they're moving, you can measure the force of gravity that's holding them together. That's what you can do with a nearby galaxy cluster. But you can't do that with the protoclusters because, by definition, they are not settled. They're not virialized yet. And so the motions of the galaxies that are falling into this galaxy cluster are dominated not by the fact that they're sitting in a potential well, gravitational potential well of a certain size, but by essentially their history, and where they've come from, where they're going to, which makes using their motions to measure the mass that's forming much more complicated.
Whoa!
So, good question. We can't do that yet. There are other ways of doing it. If you've got a really super telescope, you can look for gravitational lensing effects, etc. But that's even further off for these protoclusters, I'm afraid.
Dave, thank you so much. That was a very information-rich couple of minutes that you just did for us then. You have got a fantastic job, and thank you so much for coming on behalf of everybody at the SPA. Thank you so much.
And thank you very much for having me.
It's been a pleasure. See you on LinkedIn.
Oh, yes. You can find me there if you really want to.
Yeah,
do Twitter. And I also do Twitter, DaveCL42. And I also do have an occasionally updated blog on WordPress under the name DaveCL. So
follow that man for the latest evolution of galaxies information. Catch you later, Dave.
Okay, thanks very much. Bye.
Bye. Whee! That was good. So after 2 dismal comet failures this year, hopes are very high for comet C2020F3, also known as Neowise, which may be visible to the naked eye during July 2020. Come on, please. We're so overdue an amazing comet. This is information that you will find on the Pop Astro website, by the way. So the comet is due to make its way into the northern sky during the first week of July and become visible in the late evening sky during the second half of the month. So far, its brightness appears to be on track for naked eye visibility, although this does not mean it will be spectacular. So also we have got the SPA magazine coming out in the 3rd week of August. Look out for it. That will be the September issue. I've just been having a chat with Robin, who is the editor. We're looking for an editor for the magazine as well, by the way. So if you want to voluntarily edit our wonderful publication, please get in touch. It will look amazing on your CV and leapfrog you up the ladder into astronomy publishing with a bit of luck. So in the magazine so far, we have got a guide to observing Mars, one on the latest giant telescopes coming online, and a debate as to whether or not we will live on Mars. Now, I went to a really in-depth lecture about living on Mars, and a chap, I can't remember his name, had done the calculations about how ferociously difficult it was going to be to live on Mars. And he showed this diagram and this flow diagram, and the flow diagram was black with feedback lines on it of all the permutations of all the difficulties of living there. So I'm feeling slightly pessimistic about living on Mars. I wouldn't want to go anyway. I'm currently isolating in a large caravan. And I can tell you, after just 3 hours in here in the rain, it makes me just want to escape. So I get cabin fever very quickly. Mars will be a tough one. It will be interesting to see what they say in the magazine. So they're still putting together, Robin is still putting together the issue of the magazine. So it would be great to have your contributions and your observations. So last week, we had a lunar sketching competition. No competition this week, but we had a lunar sketching competition and we had entries. They were fantastic. Thank you to everybody who submitted. The prize was to win the most random record in the history of records. It's Carl Sagan's spoken word record featuring Stephen Hawking with the best bit, the Voyager etchings on the back of it. And it's one of those with a big hole in it. So it's touch and go whether you'll be able to play it, if you've even got a record player. So well done to Tony Dees, I guess his name is pronounced, or Days. He had done a brilliant lunar sketching of the craters, and he apologized for it being amateurish, but I thought it was very professional looking, and you definitely had all the orientations of the craters and the angles as well. And that's what won it in my book. You'd gone the extra mile, something I hadn't ever considered doing before, annotating the angles and the details of the craters. So thank you very much. You taught me a thing or two and you have won the record. So coming up now, we have got 3, 2, 1, Mark, I'm coming to you right now. Here he is.
Good evening.
Hi, Mark. How are you, Mr.
Yes.
Thompson?
Yes, I'm wonderful, thank you. I'm actually enjoying a cheeky glass of wine.
Oh, look at you. Yeah. I've got a mug of water because I'm not very rock and roll tonight.
You could have put wine in it, no one would have known.
It could be vodka.
Vodka, isn't it? Go for it. Why not?
But one of the things about trying to observe when you've had a tipple is it makes all the stars move, doesn't it? I think you enjoy Stargate. Sorry.
You get to eat all sorts of stuff if you drink while you're observing. I don't recommend it for one moment.
No, I find it interferes with my. I think every star is a satellite, basically. Going fast like that.
Everything moves, doesn't it? And it all goes all squiffy and twinkly. It's not recommended. If you want to do proper scientific observations, steer away from the alcohol, definitely.
Yeah, for sure. But there's not much chance of any of us seeing any stars tonight, so enjoy your wine, love.
I am. That's exactly this. It's cloudy. It's been raining. It's howling a gale outside. Sounds like it a little bit for you in Anglesey. So yeah, I'm going to enjoy a glass of wine instead. Very
good, Mark. So you are of BBC Stargazing. Is it ever coming back? We miss it.
Do you know the jury is out? Unfortunately, it was the commissioners liked Stargazing Live after Christmas because it was intellectual detox, they called it, because it gave some people gave people something really interesting and something that challenged their minds a little bit after all the sort of the Christmas frivolities. And unfortunately, if it's going to happen after Christmas every year, then that means that the sky essentially is going to be the same every year. Planets will move around a little bit, the other things will change a little bit, but by and large, we'll see the same things year after year. So for the moment, I'm afraid the jury is out, but watch this space. It might come back.
This is my attempt to fill in the gap left by BBC Stargazing.
And you're doing a fantastic job, Vicky, of course.
Oh, why? Thank you very much. So you have got big news then, Mark. What is your big news?
Well, so I've launched a podcast. Now, I came up with the idea of the podcast. It's called The Pocket Astronomer, and it actually made the iTunes bestsellers list. Yesterday or today? Yeah, yesterday. Oh, no, this morning. It made it this morning. So that's wonderful news to hear. It's had loads of downloads. And I came up with the idea during the dreaded lockdown that we've all been experiencing, where I was taking people on Twitter-based guided tours of the night sky. And I call it kind of hashtag Family Stargaze with Mark. And the idea was that people joined me on Twitter for half an hour of an evening, and I guided people around the night sky, posted loads of tweets, which simply said kind of look left of that big bright star that was over in the west up in the direction of the sunset. And I basically guided people around the night sky, and it all went really, really popular. But of course, what you don't want is you don't want people stargazing and looking at their phone, because phones are quite bright, and the brightness of a phone can affect people's dark adaptation. So I came up with the idea of a podcast, and the idea of it's a bit like a museum guide for the night sky. So we're going to have monthly podcasts. First one came out 1st of July. And it's a guide for showing you some of the wonders of the summer night sky. You can take it outside with you. You can stick your earphones in. You can play it. You can pause. You can skip backwards to different chapters. And it shows you some of the things that you can look out for in the sky over the summer months. And it's great fun recording. I actually go outside, Vicky, to record it as well, to get the full effect of the atmosphere at night.
Yes, because I've had a quick listen this afternoon. It's beautifully produced. It's got music on it and voiceovers and all the good stuff. It's I love podcasts.
Did you recognise who the lady was who was doing the kind of the chapter headings?
Was she American?
No, definitely not. It is none other than Lorraine Kelly.
Oh, that's a big name.
Yes. So Lorraine Kelly is a big fan of astronomy and she loves space. So I worked with her a couple of times on ITV, and I said to her, Lorraine, do you fancy just doing the sort of the chapter headings for me? And she did, and it comes over wonderful. So you get, not only do you get to enjoy my voice out in your back garden of an evening, but you get to enjoy Lorraine Kelly as well.
I would have never put Lorraine and space together, but space is for everybody, isn't it?
Absolutely, of course it is. And you know, there's an amazing array of people out there. And you know, that's the great thing about it, is that it appeals to everyone. Even you know, the dreaded subject of cosmology. I think, you know, who can't be fascinated by the origins of the universe and where the universe is ultimately going to end up. And I think the beauty of astronomy generally is that it appeals to so many different people from so many different walks of life. It's brilliant.
I think Lorraine Kelly's going to be the Sky Night's next big signing.
Do you think? I don't.
My money's on Lorraine.
She's not. I don't think she's actually a massive fan of actually getting outside in the dark and the cold too much. She's a bit of a fan of creature comfort, so I don't know if you'll see her outside too much, unfortunately.
So why is it different from other podcasts about astronomy then, the Pocket Astronomer?
Well, what I've tried to do with it is, instead of, there's a lot of podcasts out there which give you a guide for looking around the night sky, but actually what they do is they kind of tell you what you can see in the sky this month. So it's a sort of you can see Jupiter and Saturn in the evening in the west if you look west after sunset, or the phases of the moon, or there's an eclipse on a certain date and time. But what they don't do is they're not kind of live. Well, mine's not live, of course, but they're not real, almost like a real-time experience. So it's not something you could take outside and you could use it to find your way around the sky. I'm sure many of the people watching tonight are familiar with the classic fist width measurement. If you extend your arm, clench your fist, that looks massive on the camera, doesn't it? Look at the size of that. But if you clench your fist and extend your arm, then the amount of sky that covers is about 10 degrees. And it works because people with smaller hands tend to have shorter arms. So anyone who clenches their fist, extend their arm, their fist covers about 10 degrees on the sky. So I guide people around the sky using a fist width measurement to find stars. That, you know, and the key sort of selling point, I think, for me, is that people can actually take outside with them and they can stargaze with it. And that's the whole idea, is to guide people around the sky. And that's where the kind of the phrase of the pocket astronomer came from, because it's, you know, it's like having me in your pockets, having me out there with you, guiding people around the night sky.
So how do we get hold of this podcast then? Because not everybody might be familiar with podcasts. I eat podcasts every day, but how can we download it? What do we need?
So it is available on it's on iTunes, of course, on the Apple system. It's also available via an RSS feed, which is like typically used as a news feed, and it's also available on the site it's hosted on called Podbean. But if you get onto Facebook and you search for the Pocket Astro, and also on Twitter, you'll find the Pocket Astro on both of those systems, the account systems, and in there are the links to get to the podcast, and you can tune into it. And unfortunately, during the summer months, it's very difficult to guide people around the sky at a civil hour. So if you tune into it over the next week or so, then you're going to have to be up around after 1 o'clock in the morning. If you tune into it around the middle of the month, then you can use it about 12 o'clock at night. And if you listen to it at the end of the month, then you can use it about 11 o'clock. So it gets a bit more civilized as the month progresses. But of course, future podcasts will be at more civilized times. It's just because the skies don't get really dark and you have to wait until it's quite late before you can see the stars at the moment.
What a lovely idea for a podcast, Mark. Now, how have you read A Brief History of Time?
Yes. Interestingly, a lot of people seem to struggle to get past page 7, I've heard.
The index.
Not sure where that comes. I don't know what happens on, I'm sure it's page 7, or maybe it's 14. But I'm sure
is that when it accelerates? That's when it accelerates at light speed.
I'm not sure what it is, but it must be a topic in the book that people find it really difficult to get the head round and just give up. But I have read the whole book, and it was quite some years ago, but it is a wonderful book.
I think it's a good place to start with cosmology if you're looking to get into it and understand the fundamentals. Wouldn't you agree?
Yeah, absolutely. I think one of the difficulties of cosmology is that if you want to get really into a lot of the nitty gritty of it, it gets heavily into mathematics, unfortunately. And there's only so many things that you can articulate in the language of mathematics. And so I think it's very difficult to, certainly if you're talking to a general public audience, to give a really good, solid grounding in cosmology without drifting a little bit into mathematics. But you're absolutely right that there's a level you can go to without getting into mathematics. And Stephen Hawking, in The Brief History of Time, he does that superbly. And I remember when I read it, actually, I think I read it about 3 times now over the years. It's been out for quite a few years. When was it published? Was it in the 80s? I can't remember when it was published. It was published quite some time ago. But it is a brilliant book. If people are interested in cosmology, then it is a fantastic book to get yourself into it without it being too heavy. The concepts are really hard. I often tell people, if you want to learn about cosmology, you've got to kind of disconnect your common sense chip, because there's a lot of stuff in there that just jars with your sense of reality and your sense of common sense. And so I think, yeah, get a brief history of time, pop out your common sense chip, and just take it for what it is. And actually, you can learn an awful lot out of that book. It's a really good book to read.
That's my recommendation for where to start. Now, as I've been scrolling through the astronomy news today, I saw something. Do you know when you get a really cheap margarita pizza from the supermarket that's just cheese and tomato? Yeah. The really, really cheap ones with nothing else on them. Now, imagine if you burnt one of those under the grill for like 20 minutes and pulled it out. That is the latest what they reckon Beetlejuice looks like, with its star spots on it. Have you seen the image?
I have, yeah, and it's really interesting. When it dimmed, it caught us all by surprise, didn't it? And it was something that made a lot of people think, crikey, is it going to go supernova? Is it right on the edge? Because obviously it's a star which is bloated, it's swollen up. It's a red giant star which is right at the end of its life. We think it will go supernova at some point, but it hasn't yet. And when it suddenly dimmed, yeah, there was a lot of expectation from people, and certainly initially, to think that it was going to go pop. But it came back in, I think it was May this year. It started to brighten again, and everyone kind of went, oh, because it wasn't going to go back. But they think it's star spots now, don't they?
And the image, these giant dark areas that make sunspots look like pimples. The whole thing is virtually eclipsed by them. Poor Beetlejuice. But
it was a wonderful discovery. So for a while we thought it was perhaps when we realised it wasn't going to die and it wasn't at the very end of its life, for a long while we thought maybe it was a cloud had drifted, a dust cloud had drifted between us and the star, which caused its brightness to drop. But actually, I think there was a study that was looking at the sub-millimeter wavelengths from Betelgeuse or Betelgeuse, and that showed that it was dimming as well. But you wouldn't necessarily get that dimming from sub-millimeter wavelengths if the light is traveling through a dust cloud, because the dust particle does block it. And it was that actually pointed astronomers to the concept of maybe it was the star spots causing it to fade instead of the dust cloud. But I'm a little bit disappointed. I thought it would be great to see it go supernova.
Oh God, yeah, absolutely. Mark, I'd like to welcome you on board as the newest member of the Society for Popular Astronomy. So thank you for rejoining us. It's been we look forward to sending out our magazine to you. Your sound quality sadly is a little bit off this evening.
It's my broadband. It's terrible. It's like using a piece of wet string here in Norfolk, I'm afraid.
Oh dear, I'm going to ditch you now from the broadcast. It's been wonderful seeing you. Catch you later. Thank you so much.
Cheers. Take care. Bye-bye.
Bye. Oh, that was great, wasn't it? Mark Thompson, BBC Stargazing, everybody. Well, thank you to everybody who has contributed to this evening's show. It's nearly time to go. It doesn't seem like it's an hour. I mean, how long is the Sky at Night? Half an hour? They get a lot into that time, but this doesn't feel like long enough. Please do check popastro.com for our shop to join, and also our Facebook. Robin Scadgel has posted a brilliant 15-ish minute long video of the night sky throughout July using his very, very snazzy camera. It does almost look like you're looking through basically it's a guide around his garden, and you get to see what all the stars look like, very, very bright and twinkly, like it's an ultra clear night. And with Robin's fantastic annotations as well, it's one not to be missed and will really enhance your understanding of the night sky. Final shout out for joining the SPA. It's £23 per year and you get lots of goodies, benefits and bonuses. The main one for me all the time is the magazine that comes out every 2 months, which you can contribute to as well. Please like, tag, share this post. We will be seeing you next week. Now, all we've just got to do is think of a subject for next week. So if anybody would like to contribute and suggest something that you would like us to cover, that would be marvelous. Thank you to everybody who contributed. It's been an absolute pleasure, and see you all next time. Thank you very much. I've got to press the off button now and just go back to normal lockdown life. Don't want to go. Gotta go. Bye.